Just as we have properties, multiplication properties of exponents, we also have division properties of exponents. Take a look at this example right here. We have 4 to the 5th over 4 to the 3rd. Well, basically what that means is 4 times 4 times 4 times 4 times 4. We have 5 4s being multiplied together. On the bottom, 4 to the 3rd means 4 times 4 times 4. Now, if we were to cancel some of these out, 4 divided by 4 would be 1, so that would cancel out, so would those set of 4s, and so would that set of 4s, which would just leave us 4 times 4, or 4 to the 2nd. Now, if you look here at the exponents, if I can circle them so you can see it, 5 to the 3rd, 5 and 3 and a 2. There's a relationship there. And that relationship leads us to our quotient of powers property. Again, I don't expect that you memorize the names, but you do need to know how to use these properties. And as always, feel free to pause this to write down the properties. It says to divide powers having the same base, subtract exponents. So for example, they have a to the m over a to the nth. Since they're both a's, we can just go m minus n. For example, 3 to the 7th over 3 to the 5th is just 3 raised to the 7 minus 5, or 3 to the 2nd. We also have another property here, which is called the power of a quotient property. Again, just know how to use it. It says to find the power of a quotient, find the power of the numerator and the power of the denominator and divide. What that means is if you have a fraction or it's some kind of division problem, that's why I say quotient here, a over b raised to the m, that's like saying a to the m over b to the m. And of course, b cannot be 0 because that would be undefined. If we had 4/5 raised to the 3rd power, that's like saying 4 to the 3rd over 5 to the 3rd. Let's look at a couple examples. Notice here we have 4 to the 5th over 4 to the 4th. Again, same base being divided. That's like saying 4 to the 5 minus 4, or 4 to the 1st power. And we can just write that as 4. Another example is this one here. Negative 3 to the 4th over negative 3 to the 4th. Well, it's the same base. Don't cancel out the bases. And none of the properties here, they don't cancel out. They were 4 to start, it stays 4. It was a to start, it stays a. We take our base of negative 3, and since it's being divided, we subtract our exponents. 4 minus 4. This becomes negative 3 to the 0 power. Now keep in mind, just because we're working with the division properties of exponents doesn't mean we can forget all our other properties. In the last lesson, we talked about what a number raised to 0 is. Anything raised to 0 is 1. So we still need to keep in mind those properties we've previously learned. Look at C here. Sometimes it's going to take a couple steps to get to your solution. If I have c to the 3rd times c to the 5th over c to the 9th, we can use one of our multiplication properties of exponents and say, well, c to the 3rd times 6 to the 3rd times 6 to the 5th, we can add 3 plus 5 because we're multiplying same base, and that becomes 6 to the 8th over 6 to the 9th. Now at this point, remember, we can subtract them. Same base, now dividing, we subtract the exponents. 8 minus 9 is a negative 1. And keep in mind, ladies and gentlemen, you can't just say bigger minus smaller. You have to go 8 minus 9. Exponent in the numerator minus the exponent in the denominator. So this becomes 6 to the negative 1. Again, keep in mind our other properties we've learned. We know that when we raise a number to a negative exponent, we take the reciprocal. So if this was 6 over 1, it would become 1 over 6 to the 1st power. And we don't really need that 1. So just 1 over 6. Now for something like this, sometimes it's helpful to combine them and break them up. Here's what I mean. I can write this as x to the 2nd over 1. So if I multiply across the top here, I get 2 times x to the 2nd over, I'm going to switch these around, 1 times x to the 4th. Now the reason I wrote it like that is now I have two problems here I'm going to break apart. 2 over 1 times x to the 2nd over x to the 4th. Well, 2 over 1 is still going to say 2. And if I subtract these exponents, I'm going to get 2 minus 4, which is a negative 2. Now notice this 2 is not raised to the negative 2nd power. So maybe I'll continue writing it as a 2 over 1. this becomes 2 over 1 times, take the reciprocal, again if we write it over 1 over x to the second. And then take it one more time. 2 times 1 is 2. 1 times x squared is x squared. Now again, I wrote up a lot of steps, but the more you practice this, the easier it is to see. But until you get comfortable doing that, it's really pretty helpful to write down as many steps as you can.